Hello, I hope you all are doing well. My name is Chirantan. I am pursuing my BTech in the Indian Institute of Information Technology, Guwahati. I am part of the 2021 to 25 batch at IIITG, and today I wish to teach you the topic of projectile motion. Now, as a prerequisite to projectile motion, it is imperative that we discuss the three equations of motion, which form a rather important part of kinematics as we know it. The notion behind the three equations of motion is that if an object starts moving with an initial velocity of u and an acceleration a is applied to it across a time period t and such that it attains a final velocity v and covers a distance s, then the three equations of motions are stated as follows: v equals u plus at, s equals ut plus half at square, and v square is equals u square plus twice s. Now, with these three equations in mind, we shall now study the motion of a projectile. Again, we are going to assume there is no air resistance, and we are going to assume uniform value of the acceleration due to gravity g throughout the surface that we will be studying. So let me assume that this is the ground level, this is a point object, and it is thrown in such a way that its initial velocity is u at an angle of theta from the ground. From common observation, we know that the object will cover a parabolic path and it will land at a distance, say r. The time for which this object remains airborne is known as time of flight and denoted as capital T. Now, it is also true that this object will attain a maximum of height h. That is, its climb will be up to this height h. So, how is it that this object covers such a relatively complicated path? To understand this, we begin here. This is the velocity vector u. Now let's split it into its components. The vertical component is u sine theta and the horizontal component is u cos theta. Now, because there is no air resistance, u cos theta remains constant in our experiment, and the distance r we can conclude is u cos theta t. Now, because of no air resistance, we can also conclude that the time it takes for the object to reach the maximum height h is the same time that it takes from this maximum height to ground. In other words, both these time phases will be t upon 2. Now, let us look at the motion of the object along the y-axis. At any given time t, we can say that the height of this object is y equal to u sine theta t minus half gt square. Note that this is during the climbing phase because g is acting downward and the velocity is acting upward, so the acceleration is acting opposite of velocity, hence the negative sign. This is the equation for y. Now, let us also remember that we have this as the first equation of motion, v equal to u plus at. We shall now use it. See, when the object is climbing to its maximum height, its final velocity is destined to become 0, because again acceleration is acting negative to the velocity, so it will decelerate it to 0. It starts off at u sine theta, acceleration is negative g, and time is capital T upon 2. So let me take this here, gt upon 2 equals u sine theta, and t equals twice u sine theta upon g. This is the formula for the time of flight of the object. Now let us note it down once again here, t equals twice u sine theta upon g. Now remember that y equation, y equal to u sine theta t minus half g t square. Let me substitute t with t by 2. Why t by 2? Because this is the climbing half of the story, not the descent. And we know that the maximum height will be h. So h equal to u sine theta, t is t by 2, and t by 2 is, as you can calculate, t by 2 is u sine theta upon g. U sine theta plus half g u square sine square theta by g square. See, so u sine theta is u square sine square theta by g minus g here, g down there to the power 2, so u square sine square theta by 2g. So if we take u square sine square theta by g common, we'll have 1 here, half here, so 1 minus half is half, so u square sine square theta by 2g is the maximum height attained by the object. And as you may recall, this is the time of flight. Now we have looked at the perpendicular side of things. Now let's look at the horizontal part, and the horizontal component was u cos theta. There is no acceleration acting on this object in any direction, so it will be constant for a time of capital T, the entire time of flight. And so we recall that t equal to twice u sine theta upon g. Now we can use distance equal to speed times time, that is range is equal to u cos theta times t, which is equal to u cos theta twice u sine theta by g. So r equal to twice u square sine theta cos theta by g. This is the formula for range. So we have calculated the formula for maximum height, we have calculated the formula for time of flight, we have calculated the formula for range. There is one final formula that we need to derive. That formula is the trajectory itself. See, if I assume that this is the y-axis and x-axis, then this is a curve that has a formula. So what is that formula? Let us try to find it, and the answer to that lies here. This is the equation that we use to derive maximum height. Now all I need to do is introduce x here, but how will I do it? Let me assume that, instead of the whole time t, let me assume a different time interval t. So in time t, this object would have covered an x distance of u cos theta t. So I can write x equal to u cos theta t, that is t equal to x upon u cos theta. If I substitute this here, t will be eliminated, and in its place x will be introduced. So let me do that right now. Y is equal to u sin theta x by u cos theta minus half g x upon u cos theta whole square. U and u are cancelled. Sin theta upon cos theta becomes tan theta, so x tan theta minus gx square by 2 u square at theta. That, my friend, is y. So the trajectory of this projectile can be derived using this formula. So to conclude, we have derived the following formulae. There. So time of flight t is twice u sin theta by g. H is the maximum height, which is derived as u square sin square theta upon 2g. R is the range, and it is derived as 2u square sin theta cos theta upon g. And the path of the projectile can be denoted as the function y equal to x tan theta minus gx square by u square cos square theta. So that would be all for today. Thank you, and I hope this lecture was informative.